starting the quiz, right? We are starting with the quiz of electricity class 10, right? So there will be questions on electricity obviously in this quiz, and we will be focusing mainly on the chapter and all the questions. Are you ready? Take a copy and a pen, so that you can do the calculations also. Be ready with the copy and pen, and what we'll do is I tell you the rules of the quiz, right? So what are the rules? Obviously it's a multiple choice question session, and you have to write the answer within the comments within 30 seconds, right? 30 seconds is what is allotted to you to answer the question, and write the answer in the comments. First answer will be considered as the correct answer. It's not that you will keep on answering A B C D, koi to sahi hoga, not like that. First answer will be considered as the correct, right? Also, you in your copy make two three columns, right? First column, write your answer, your first answer, then correct answer, then the column which beside it, column will say the correct answer. If your answer matches the correct answer, which I will explain after every question, so you will just take it over there. 1 marks for one question. Total there are 40 questions, right? So be calm, So the first question is here. Come on, I am starting the timer. Okay, giving you some time to read the question. A cell, a resistor, this is the cell, resistor, key and ammeter are arranged in as shown in the circuit diagrams of the figure. The current recorded in the ammeter will be maximum in 1. There are 3 figures and saying the current maximum in 1 or maximum in 2, maximum in 3. You have your 30 seconds started. It's an easy question. Just think over it. See the arrangement, how it is done, what goes through your mind. All the 3 cases. I don't think 30 seconds is necessary to answer this question. Okay, 5 seconds more. 3, 2, 1. Okay, time over. So as you can see here, pause it. Will take the pen. Okay. So what you can, this is the positive terminal, negative terminal, the resistor is there, key is there, right? And the resistor, key, ammeter over here. Yes. So what is that we can see? Ammeter is always connected in series. So is it connected in series? Yes, minus is there, minus resistance of series mein, again here minus connected. The connections are correct. All the 3 connections are correct. The value of resistance is same everywhere, right? And the potential difference is not given any value, means we will consider that all the potential that is applied is the same. So what do we get? We get that the reading of the ammeter is same in all the cases. So the correct option is D, right? If your answer is correct, just write your answer, my answer, correct answer. So you will write here D and here correct D, and make sure to write the answer in the comments also, right? This is for your evaluation and this is for my evaluation, right? At last we will compare both are right, both are correct or not, whether you have done all the imandari work or not. Okay. So next, in the following circuit, heat produced in the resistor or combination of resistors connected to a 12-volt battery will be, right? Heat produced in the resistor or combination of resistors, है ना, either the resistor or combination of resistors. So the timer is starting. As you can see, there is only one resistor here, two here, and two also here. So the heat produced in resistor or the combination of resistor. You know the formula for combination of resistors. Timer was having some problem. We'll get some more time. Come on, your time to think. There is only one, and all are having the same value, 2 ohm, 2 ohm, 2 ohm. So let's see, 19, 20, 21, 30. Time over. So let's see, यहाँ पे ये R1 R है, ये भी R, ये भी R, but what you can combination of resistors के बारे में बात कर रहे हैं here. So obviously one resistance you can write instead of both, that will be 4 ohm, है ना. This is the combination of the resistor. So this circuit can be changed into this circuit, right, and this circuit can be changed into this circuit, right. I'm changing the figure. This will be R equivalent. Again, to calculate 1 by 2 plus 1 by 2 equal to 1 by R equivalent, right. So the LCM is 2 and you will get here 2, 1 by R equivalent. So R equivalent is 1. So if R equivalent is 1 ohm, if R equivalent is 1 ohm, right, 1 ohm. So 1 ohm, what will you see यहाँ पे 12 volt, the current will be 12 ampere, right. So we will find one by one. Here I square, here the current will be 6 ampere, right. Here the current will be V equal to IR, V equal to IR, R is 4, it will be 3 ampere, है ना. Here 12 ampere. So let's find out I square RT होता है ना heat का formula, I square RT. Here heat is 6, current is 6, so 36 into 2. Time we are not taking consider, time is T over here also, okay. So again H in this case H2 I am saying, here I am saying H2, H1, 6 to the 12, 3 to 6 1 72 T, है ना. Here 3 3 is 9, 9 4 is 36 into T, so 9 4 is 36 T. That's what I am getting over here. Now here H3, I is 12 into 12, है ना, I square RT, R is 1 ohm into T, right. So 12 into 12 into 1 into T, so obviously 72, ये 144 T आ गया. This will be maximum. D option is the correct one. Is it clear, है ना. The question was asking here, we know that these two resistances can be replaced by one single resistance, and one single resistance will have how much value, the equivalent of, right, 1 by 2 plus 1 by 2, they both are in parallel. 1 by 2 plus 1 by 2, 1 by R equivalent. So we'll take 2 LCM, 1 plus 1 2, 2 by 2 1. So that's what we'll get the answer, maximum in case 3. Is it clear? The correct option is D. Okay. Electrical resistivity of a given metallic wire depends on think over it. It's not much to think. I think 10 seconds, 12 seconds will be enough. है ना? Now this is what in the competitive exams you must know. कि there are some questions which are just, you just see them and answer them. So these questions will save your time for the other questions. है ना? Okay. Now Electrical resistivity, obviously we know it doesn't depends on length, doesn't depends on thickness, doesn't depend on shape, it depends on nature. So the correct option is D. So all the three questions that we did, the correct option is D. So the correct option here is D, right? Resistivity, electrical resistivity is denoted by rho, and rho is defined as the resistance of unit length and unit मीटर स्क्वायर एरिया, यूनिट लेंथ एंड यूनिट एरिया, वही ना, ठीक है, रेजिस्टेंस ऑफ यूनिट लेंथ एंड यूनिट एरिया. Shall we move forward? Okay. Next, a current of 1 ampere is drawn by a filament of electric bulb. Number of electrons passing through cross section of filament in 16 seconds. Time is starting. 30 seconds. Come on, try to solve it. This is a very easy question, है ना? You need to know some formulas. What is current? Flow of electrons, right? Obviously, it's asking the number of electrons. What will be the number of electrons? Time is given, 16 seconds. So in that time, how much electrons will be passing? It's asking that. ठीक है, time over. चलो, we'll solve this. I equal to 1 ampere. Okay, very good. Now the time is given 16 seconds. Very good. But we know the formula that I equal to Q by T, where Q is the charge number charges, and Q can be written as NE by T. Here we know that I equal to 1 ampere. 1 ampere equal to number of electrons into charge on 1 electron. Charge on 1 electron 1.6 into 10 power minus 19 coulomb. And the time that we have is 16 seconds. Ampere, coulomb, second has to be there. 1 into 16 divided by 1.6 into 10 to the power minus 19 is equal to n. So if we remove this decimal, we get 10 over here, and this 16 is cancelled. This 10 power minus 19 will go up. 10 into 10 power 19 will be 10 power 20. So the correct answer is option A, right? The correct answer is option A. Okay. Next, 5. Identify the circuit. This is a circuit diagram, 4 different circuit diagrams, and you have to identify in which the electrical components have been properly connected. And it's not asking which are improperly connected. It's asking, the time is started, so come on, think over it. There were some rules to connect the appliances, the measurement devices to a resistor. That's what we are talking about. I have to think about that only. So please think. Okay, the time over. Okay, let's see. The resistance is here. No, this is positive, this is negative. The voltmeter is never connected in series. So here this is gone. This option is wrong. Voltmeter is connected in parallel. Ammeter is connected in series. Very good. So this is can be considered. Again here voltmeter is in series. So this is cancelled. Ammeter is never connected in parallel. Here both are in series. So this is okay, but this is wrong. Here this is wrong, and this is also wrong. Now here voltmeter is in parallel. Here also voltmeter is parallel. Ammeter is in series. But there is a minute difference. You see, here the negative terminal is connected to the positive terminal. So that's what is the mistake in this question. Clear? So this will be the correct option, right? So you have to observe for the minute observations also. Otherwise this will make the question wrong. Okay? Is it clear? Shall we move? So the correct option is B, or right? Okay. Now this question, what is the maximum resistance that can be made using 5 resistors each of 1.5 ohm? Think over it. And time is started. It's an easy question, either you can connect it in series or parallel or a mixture of both. Resistances can be connected like that only. 4, 3, 2, 1 on. Okay, let's see, you have resistance value of 1 by 5 ohm, right? You have value 1 by 5 ohm. Now what you have to do, you have to find the maximum, so if you connect it in series, so what you will get, R equivalent equal to 1 by 5 plus 1 by 5 times 1 by 5, let me write 5 times. Okay, this means 5 into 1 by 5, this means how much? 5 into 1 by 5 is 1 ohm. So the equivalent resistance that you are getting is 1 ohm. But here in the other case, formula is 1 by R equivalent, parallel, 1 by 5 plus 1 by 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 1 by 5. Now if you know the main division is here, so 5 will go upward, so we will have 5 times, so we will have 25 ohm. But 25 ohm is not the correct, not 25 ohm actually. The value that we are getting is 1 by R equivalent, 1 by R equivalent. So R equivalent will be how much? R equivalent will be 1 by 25 ohm, right? So the obviously 1 is greater than 1 by 25, right? So the maximum that we will get is 1 ohm. The correct option is D. Correct option is what? D. I hope it is clear. That's what. Chalo. Next. The question is not the same. It is saying what is the minimum resistance which can be made using 5 resistors each of 1 by 5 ohm. Here it was maximum. Here you have minimum, right? So time is started. Same type of question, difference being only in maximum and minimum. Think over it. Easy, right? Like same as the previous question. Most of you have got the answer also. Okay, 3, 2, 1. The time is up. Okay, now we solve this question just now. If we connect 1 by 5 ohm resistances in series, then we are getting 1, and if we are connecting them in parallel, then we are getting how much? 25. We are getting 1 by 25. Obviously minimum की बात करेंगे तो 1 by 25 is correct, right? So the B option is right. Clear, right? 1 by 25. Chalo. Next question. I will not explain it. It's enough to be answered in 30 seconds. The proper representation of series combination of cells. Yes, there was a difference between the cell and battery. Why do we call, what is the representation of cell and what is the representation of a battery? There is some difference in it, so you have to think over it. What is the correct? Okay, so let's see here. This is positive, this is negative, this is positive, this is negative, this is positive, this is negative. Do we connect our battery cells like this only in series, right? So this is a different kind of arrangement. This is plus minus minus plus. This is not the way we arrange series combination, and this is so wrong. Plus minus and here minus plus plus. This is wrong, right? This is also plus minus minus plus minus minus plus. So wrong. As you know that the bigger line denotes plus, the smaller denotes minus. So that's what. Clear or not clear? So the correct option is 1 or A. Right? Okay. Next. Chalo start solving. Time started. Which of the following represents a voltage out of the 4? Work done by current into time, work done into charge, work done into time by current, or D, work done into charge into time. You have to think. Okay, time is over. Now we know that the formula for voltage is W by Q. Work done in bringing unit per unit charge, unit positive charge from infinity to a point in the electric field. And this is work done by current into time. We'll see one by one. Now work done is W, current is I, time is T. So can we write I as Q by T? W by Q by T into T. T cancel. We are getting W by Q. So isn't it the correct answer, right? Okay, the option was A, so we got the correct answer in the first only, but we will check all of them. Work done, W into Q into T. This is not the formula for voltage because T is extra coming up. Work done into time, so W into T by I. Neither this is the, because again I is not required. Work done into charge, work done per unit charge is voltage. So the correct option is A. Clear? Chalo next. Right? Will you start solving or take some time? Okay, take some time to read the question. A cylindrical conductor of length L, uniform cross section area, has resistance R, and the conductor of length 2L and resistance of the same material has area of cross section. There are some hints, some concept is needed. 32 seconds started. 2 seconds. Think over it. There is some concept of, like, give a hint. Resistance is there obviously, and some more concept. Okay, I will not tell. 3, 2, 1, gone. Okay. Now, a cylindrical conductor, length L, cross section area A, has resistance R, and the conductor of length 2L. So firstly, if it has R resistance, the formula will be rho L by A, right? This is the formula of the resistance. Now another conductor I have of length 2L, so let the resistance be R because it is saying ki same resistance, so the length is different, it is 2L. Same material. Now what does this word mean? Same material means that resistivity is dependent on material. So if the material is the same, the resistivity will be same. So rho into 2L by A dash. I don't know A, I have to calculate A. So R, we'll just change it. We need to find A dash. So A dash will be equal to rho into 2L by R, and here A is equal to rho L by R. Okay, we have to compare A dash and A. That's why what we'll do, rho L by R is A. So instead of 2, we'll write like this. We are just rearranging it. It's a foolproof method of solving. So instead of rho L by R, can I write A? Obviously. So I write A. A dash equal to 2A. So the option is C. Correct option is C. So here two concepts are used. Firstly, the formula for resistance, resistance equal to rho L by A, and secondly, because the material is the same, so resistivity is the same. This was the concept that was used. So is it clear? That's what. Okay. Next. Okay, let me give you some time. A student carries out an experiment and plots the VI graph of 3 samples of nichrome wire with resistance R1, R2, R3 respectively. Which of the following is true? Right? So there is some trick in the question. Hidden trick, you have to see it, how to solve it. Now, these MCQ questions have become very important, because 20 questions are coming in an exam from these MCQs. So you need to be okay. The time is over. Okay. So what it is saying, ki VI graph. The thing is ki it's saying that the student plotted VI graph, but here it is given in the question IV graph. Right? So the graph plotted is IV graph. So as we know, the slope of VI graph gives us resistance. Slope of VI graph. When I say VI graph, it means I am plotting voltage on the y-axis and current on the x-axis. But when I say IV graph, means I am plotting I on y-axis and voltage on x-axis. Right? So they both are different. So when I will have an IV graph, then slope of IV graph does not give us resistance, it gives us reciprocal of resistance, 1 by resistance. Because this is IV graph, the slope of IV graph will give us 1 by resistance, right? So maximum is the slope, maximum is the value of the reciprocal of resistance. So that's what. Here this line is closer to the y-axis, which is more inclined, it has more slope. So obviously the slope of this line 1, 2, 3. I am talking about line 1, 2, 3. The slope of IV graph is there. So obviously slope gives 1 by R. So 1 by R1 is greater than 1 by R2 is greater than 1 by R3. Now we obtain this. Now because 1 by R1 is greater than 1 by R2, which is also greater than 1 by R3, matlab if you have like this, 1 by 5 is greater than 1 by, right, you know na, like this, this is a bigger number because the numerator is same in both all the three cases, 1, 1, 1, and you have the denominator, larger one. That's why so obviously the 10 is greater than 6, greater than 5. So we get R3 is greater than R2 greater than R1, right? So what we get the correct answer as? Correct answer is C. The correct answer is C, right? Is it clear? There are two concepts which are involved in this case. Okay. Let's move forward. 12. Just read the question. If a current I through a resistor is increased by 100%, assume that temperature remains unchanged, temperature is not changing, the increase in power dissipated will be. That you have to calculate in percentage only. Okay, let's start the clock. Think over it. Some maths, maths. H.C. Verma in his book has perfectly defined the relationship between physics and maths. He has said, if you have to reach to a destination called physics, then maths is the deluxe coach. It provides you the comfort You can reach by any cycle also, but the comfort of deluxe coach is provided by maths. If you are good at maths, then it will act as a deluxe coach. Okay, let's get started. Time is over. So what it is saying, ki current is increased by 100%. So previously the current was I. Now the current is changed to I dash. I dash is how much? It is I plus 100% of I. 100% of I is again I, and 100%. So obviously we get how much? 2I, right? So what is power? Power when the current was I was I square RT. Now the new power dash is again I dash square RT. So I dash is what? 2I. So we'll get 4I square RT and a power dash, and this is P equal to I square RT. Again the same method, P equal to I square RT. So P dash equal to I square RT के बदले हम लोग P लिख लेंगे, तो equal to 4P है ना. परसेंटेज इंक्रीज इन पावर निकालना है. परसेंटेज इंक्रीज, ना परसेंटेज इंक्रीज ऑफ एनीथिंग इज इक्वल टू द increase by original into 100%, right? So what is the increase? Increase is 4P, and increased value minus P original value by the original value into 100%. So obviously 4P minus P is what? 3P. 3P by P into 100. ठीक है? So we'll get 300%. 300% is the correct answer. So option C is the correct answer. Clear? So the C option is the correct answer. Is it clear? So this is the way you have to calculate. Yes, percentage increase formula you should know, right? Increase by original into 100. Similarly, percentage decreases, decrease by original into 100%. Okay, this is an easy question. Wait, I'll give you only 20 seconds for this. Come on, I want the answers fast. Everyone should send in correct answers. Done? Okay. Resistivity does not change. Does not change. This thing, resistivity does not change. Right? See, material is change. If we change the material, the resistivity will change, right? Clear or not? Listen to the see the question very carefully. Resistivity does not change. रेजिस्टिविटी चेंज नहीं होगा. अगर कब मटेरियल चेंज होगा तो रेजिस्टिविटी चेंज हो जाएगा. डज नॉट चेंज पूछ रहा है. टेम्परेचर चेंज होगा तो भी. तो यहाँ पे शेप चेंज होगा तो शेप का कोई इफेक्ट होता है क्या रेजिस्टिविटी पे? शेप हैज नो इफेक्ट, है ना, ऑन रेजिस्टिविटी. सो इवन इफ यू चेंज द शेप, द रेजिस्टिविटी विल नॉट चेंज. ठीक है, क्लियर? The correct option is C, है ना? Clear? Okay. Next question. So you read the question for 2-3 seconds and then electrical circuit, 3 incandescent bulbs A, B and C of rating 40 watt, 60 watt and 100 watt are connected in parallel to an electric source. Which of the following is likely to happen according to the brightness? Brightness, है ना? Brightness related to what? Power, है ना? And that's what is given power rating. 40 watt, 60 watt, 100 watt. And one more thing, bulbs are connected in parallel or in series. Does that matter? है ना? If they are connected in series and they are connected in parallel, does that matter? think over it. Okay, time over. Now connected in parallel, the bulbs are connected in parallel, है ना? If the bulbs are connected in parallel, and it is clearly given, if one is of 40 watt, other is of 60 watt, another is of 100 watt, right? So obviously the bulb which is of highest wattage will glow the brightest, है ना? So what, obviously the bulb brightness of all bulbs will not be the same. That's why we sometimes, you must have seen, we use night bulb. The wattage of that night bulb is very less, है ना? So it gives less brightness, and that's what is power rating all about. Power rating means related directly to brightness. So this is wrong. Brightness of bulb A will be maximum. No, it is of 40 watt. How can it can be maximum? Brightness of bulb B will be more than bulb A. It is 60 watt, 40 watt. Yes, possible. But let's check fourth. Brightness of bulb C will be less than. No, C is 100. Can't be less. The correct option is C. 60 watt bulb will glow brighter than 40 watt bulb. So the option C is correct. Clear? Okay. Next question. Question number 15. 15. Okay. Shall I start the timer? Read the question. Starting. Okay. You need to draw a diagram. You can draw it. है ना? Found the answer or not? Think over it. 27, 28, 29 and 30. Time over. So what you can see, two resistors of 2 ohm and 4 ohm are connected in series to a 6 volt battery. Now they are connected in series. So this is 2 and this is 4. 2 ohm and 4 ohm connected to a 6 volt battery. This is 6 volt. You can change this to, है ना, series. They both are in series, so obviously the equivalent resistance will be 6 ohm. Algebraic addition. So this will be 6 ohm and this is 6 volt. V equal to IR. So obviously 1 ampere will be flowing through it. So here in series, that's what happened. Same current flows through both, right? So heat dissipated in the 4 ohm resistor in 5 seconds. Heat dissipated, formula is I square RT. Heat is equal to I square, means the current flowing is 1 into resistance is 4. It's asking for 4 ohm. So 4, 1 square is 1 only, and time is 5 seconds. So obviously 20. Answer will be in joule. Why? Because this is in ohm, this is in second, this is in ampere. The answer will be 20 joule. So C option is correct. Clear or not clear? Here also two concepts are used. Firstly, the equivalent resistance and the current flowing. Current flowing is same through both the resistors if both the resistors are connected in series. I think it is clear. Okay, next. An electric kettle consumes 1 kilowatt of electric power when operated at 220 volt. Now what fuse wire of what rating must be used? Right? Okay. Timer started. Chalo over. So what it is saying, kilowatt, right? Electric kettle is there. The power that we have is 1 kilowatt, है ना. We know the use of fuse we use so that the only limited amount of current, the current which is required to flow through it, so that it should not burn when some extra current is flowing through the circuit, है ना. So that's what is used as a safety appliances for our appliances as safety purpose. So the voltage is 220 volt, right. So we need to find the current. So we know the formula P equal to V into I. So 1 kilowatt means how much? 1000 watt, है ना. SI यूनिट में बात करेंगे हमेशा. 220 volt into I. So this is what the kettle is operating at. So what we get, 250, right. Obviously we'll find in 10 point 11 4 jo 44, right. 6 11 5 is 55 again. So minimum the kettle should need 4.5 ampere of current. So if you use a fuse of 4 ampere, it will not be able to pass 4.5 ampere current, because it will get fused at 4 ampere itself. It will get burnt, neither 2 ampere neither 1 ampere. So obviously what you can use, 5 ampere, है ना. 5 ampere will be the correct. Clear or not clear? 5 ampere will be the correct one. Got the question? That's what you have to do, है ना. चलो next question. This is easy. Come on. Two resistors of resistance 2 ohm and 4 ohm when connected to a battery will have same current flowing through them, same voltage. It's easy or not easy, right. Time is over. Now see, there are two resistances, one is 2 ohm and the other is 4 ohm. Now the question is saying they will have the same current flowing when connected in parallel. When they are connected in parallel, then they don't the same current, and also because the values of the resistance are same current can flow, but the voltage has to be the same, which is obviously equal in parallel, but the value of resistance have to be same. The first option is not there. Same current flows them when connected in series. Yes, this is correct. Same potential across them when connected in series. No, not at all. Same different potential difference when connected in parallel. There should be same potential difference when connected in parallel, right. In parallel, when they are connected, the potential difference is same. The correct option will be D. Clear? Okay. Next, unit of electric power may be expressed as, this is a super fast question. Come on, 10 seconds. Come on, fast. Yes, I'll give 20 seconds for this only. This is an easy question. Okay, time over. Electric power may also be expressed as volt, V, ampere, I. Is this the formula for electric power? VI. Voltage, VI. Kilowatt hour. You know kilowatt hour? Kilowatt hour is unit for electrical energy. This is wrong. Watt second. Watt second means what is unit of power? Power into time. Unit of power is power into time. No, not at all. है ना? Watt is itself a unit of power. Watt second is not the correct answer. Joule second. Joule is energy and second is time. Energy into time, no. Power is energy by time. You can write joule per second. Energy मतलब joule per second is the correct unit of electric power. So we get as volt ampere is the correct option. So A option is the correct one. Volt into ampere. Clear? Next question. Now this is some question, huh? Come on, equivalent resistance you have to find it. 30 seconds. Between A and B. Between A and B. You have to find equivalent resistance between A and B. The time is gone. Okay, so here as you can see, the current starts flowing. If the current starts flowing from here, current starts flowing, it will go here and it will be distributed. It will be distributed, right? So because it will be distributed, so let me change the color of the pen. Yes, so here it will be distributed, but the same current will go over here. This means that 2 and 10 are in series. This is the thing that we have seen, divide and rule. So here this is 12 ohm, this is 4 ohm, and these two are also in series, 3.5 and 2.5, because here the current will flow in this way only. So 3.5 into 3 to 5 and 1 6, right? So here 4 ohm and here 6 ohm, and this is the point A, this is B. So this shows that they all are connected in parallel. So again we will find the formula. 1 by R equivalent is equal to 1 by 12 plus 1 by 4 plus 1 by 6. We take LCM 12, right? Take 12 LCM. Now 12 ones are 12, 4 threes are 12, and 6 twos are 12. What we get? 6 by 12. If we get 6 by 12, so this gives 1 by 2, and R equivalent is 2 ohm. Clear or not clear? Done? Okay. This is what is this question is all about. Clear? Next. Find the equivalent resistance between A and B. Find the equivalent resistance between A and B. The correct answer was 2 ohm in the previous question. Okay. Now find out the equivalent resistance between A and B. Timer is starting. 30 seconds. Come on, think over it. Think. Whenever this type of questions come, do think in terms of the path followed by the current. What path the current follows? The path. Right? Think over it. Think over it. Here you have to just calculate the resistance. There is no need of potential over here. Okay. I get some more time because it was a long question. Okay. Come on. Let's get started. So what you can see here the current is going here, current is coming here. So this 2 ohm and this 2 ohm, are they in series? Okay, that's what we'll do. Here we'll take A, simplify the circuit. This is 2 instead of those two, what we'll write? We'll write 4, right? And here 1 2 ohm was in parallel with, and this 2 ohm is in parallel with the equivalent resistance of this 2 and 2. So this is 4 ohm and this is 2 ohm. Again 2 ohm, again 2 ohm, and just keep following the path. And again these two are in series, so we write there 4 ohm, here 2 ohm, 4, and again one resistance 2 ohm is in parallel with it, right? And again one 2 ohm. So this is your simplified diagram, right? So this is 4, this is again 2. Now instead of this, and the equivalent resistance that will come for this 4 and 2 will be in series with the others, right? So what we'll do, we'll just find out 1 by 2 plus 1 by 4 is LCM is 4, 2 2 ja 4 plus 1, right? So the equivalent resistance will be 4 by 3, right or not? 4 by 3. So we'll divide it, 3 ones are 3, 1, so it is a 9. Clear or not clear? 1 by 2 plus 1 by 4, here we get 2 plus 1 4 by 3, so 1.3. 2 again will just write, instead of these we'll write one resistance as 1.3 ohm, and again over here also same thing is there. So what we'll write here, 1.3 ohm. Now everyone is in series, 2 to 4, 6, 7, 8, 8 plus 1.3 plus 1.3, 2.6, you get 10.6 ohm. I hope it is clear, है ना? That's what we have to find out. Clear? Okay. Next question, है ना? What is the rate of flow of electric charges? Come on, 10 seconds. Rate of flow of electric charges. Very easy, 10 seconds only. है ना? Potential. Electric current obviously, right? Electric current, C. Rate of flow of electric charges. Which charges? Negative charge. Okay. Again 10 seconds. SI unit of electric current. Easy. Obviously ampere is the correct option. Ampere, right? B option is the correct one. Okay, which instrument is used for measuring electric potential? Come on. Obviously potential, voltage, yes, the hint is in that only, voltage, voltmeter. C option is the correct one. ठीक है, these are the easy questions. Okay, now again, when one unit electricity moves from one point to another in electric circuit, then the amount of work done in joules is, how much? Potential difference. D option is the correct one. Clear? Amount of work done in moving, electric charge moves from one unit, है ना? It's clearly given, one unit electric charge moves from one point to another electric circuit. Amount of work done in joules is potential difference. Okay. Next, the hindrance. Again, very less time you should take. Hindrance presented by material of conductor to smooth passing of electric current is known as, hindrance is called as resistance. है ना? Okay, next. Potential difference is defined as, Come on, think. 42, 43. Okay, time over. You know, the amount of work done moving a unit charge is okay, but not in unit time. This is not, time is never considered in potential. Distance we need to know, length of conducting wire, no, amount of work done moving a unit charge. This is the correct fourth option, or D, whichever you can write. Next. Okay, the two forms of energy released by tungsten filament used in bulb are obviously light and heat, है ना, 2 or B option. Electrical and light has no heat, and electrical only, right? So that's correct. Next, the resistance of a conductor is directly proportional to resistance of a conductor is equal to directly proportional to the area of cross section. Directly, directly. Okay, it's enough, length, cause, right, directly proportional to length and inversely proportional to A, and then the formula comes R equal to rho L by A. Clear? Okay, correct option is D. Aren't these questions easy, right? So these will obviously give you confidence. We'll keep on practicing like this. The purpose of rheostat is, rheostat, you have heard rheostat, to increase the magnitude of current only, decrease the magnitude of current, increase or decrease the magnitude of current, and none of these. What does a rheostat do? We use it in verification of Ohm's law, right? So obviously its work is to increase or decrease the magnitude of current. Clear? Okay, so option C. Next, verification of Ohm's law. Point to be kept in mind: ammeter and voltmeter should be connected. Is totally wrong. Voltmeter is never connected in series. Ammeter should be connected in series and voltmeter in parallel. Totally correct. Yes, ammeter in series and voltmeter in parallel. Ammeter in parallel and voltmeter wrong. Both in parallel wrong. So correct option is B. Right? You remember the arrangement. This is the resistor whose resistance you have to find out. Right? Here we will connect the voltmeter, and somewhat key will be here, and we'll connect the ammeter over here, and the rheostat. So here rheostat will be there. This is the arrangement of Ohm's law, right? Next, so come on, solve it. 30 seconds. 40 volt battery is connected across an unknown resistor. There is current of 100 milliampere in the circuit. Find the value of the resistance of the resistor. 23, 24, 6, 27, 28, 29, 30. Done, right? So what it is saying, the voltage is given 40 volt, and there is an current of 100 milliampere. Do remember, we have to convert it into ampere, because the answer is asked in ohm. So obviously milliampere will convert, so we will have to divide by 1000, then it will come in ampere. So we are getting 1 by V equal to IR. You know the formula. V is 40 volt, I is 1 by 10, I is 1 by 10, because two zeros are already cancelled, and into R. So answer will be 400 ohm. So option is not there, so none of the above. So obviously which option is correct? Option D is correct. Clear? Okay, next. A battery of 6 volt is connected. Okay, solve it. 6 volt is connected. Battery of 6 volt is connected in series with resistors 0.1, 0.15, 0.2, 0.25 and 6 ohm. How much current will flow through the 0.3 ohm resistor? Think over it. Okay, the time is over. Okay, all are in series, right? 0.1, 0.15, 0.2, 0.25 and how much? 6, connected across 6 volt. How much? 6 volt, right? So all are in series. And how much current? Obviously 0.3 ohm. Did I miss 0.3 ohm? There is no 0.3 ohm resistor. So the question may be either 0.2 or 0.25, whatever, because there is no 0.3 ohm, so obviously we will taking 0.2. Okay, 0.2. And because all the resistances are in series, so the same current will flow through all. So we just need to find the equivalent resistance. 6 plus, we add all of them, 0.25, 0.2, 0.15 and 0.1. What will you get? 5, 5, 10, 2 to 4, 5, 6, 0.7. So it will become 6.7 ohm. We know V equal to IR. V is how much? V is 6. I we have to find out. And R is 6.7. So we divide 6 by 6.7. You get I. Clear? Now let's find out 6 by 6.7. Okay. 67, 60, 0. 63, 6, 6, 8 job 48, 49, 50, 51, 52, 54. Yeah. Okay. 0.8. So I think the A option will be right. 0.895 is coming. So 0.8. So close option answers will not give. So obviously this is correct. A is your correct answer. Okay. Okay. Next, resistance. Come on, tell me. Resistance whose VI graph is given below. What will happen? Easy question. Come on. Think over it. It's a graph question. Graph. Slope, slope. The slope of the graph gives the resistance. So here the graph is VI graph. So the slope will give us the resistance. Now we match the values first. Not right. Wait. Take it over here. Not exactly matching, right? So it's not coming here also. So obviously this 9 is for 15, this 6 exactly it should come over here, and here it's not coming, here it's coming, and how we can scale is also not given. Okay, so question is kind of okay. We'll take 9 with 15, 6 with 10, and 3 with 5. Okay, so obviously this point we call 15 comma 9, this will call 10 comma 6, and this will be called 5 comma 3. Now slope, what is slope? Slope is y2 minus y1. 9 minus 6 by 15 minus 10, what do we observe? 3 by 5. Let's check if it is straight lines, and it should validate with everyone and with all the three values. So again 6 minus 3 by 10 minus 5, what do we get? We get again 3 by 5. So okay, it's giving right. So we'll now take between C and A. 9 minus 3 by 15 minus 5. 9 minus 3 is how much? 6 by 10. 2 3s are 6, 2 5. Yeah, all the three values are same. So obviously my answer is 2 or B, right? Clear? The question was, the graph was not, the line was not actual up to the mark, but okay, no issues. In your exam the graph or the marks will be clearly visible, है ना? Okay, this is a very easy question, only 5 seconds, come on. Okay, direction of conventional current is from, conventional current is asking, is from positive terminal to negative terminal, है ना? Second or B option is correct. Clear? Electrons flow from negative terminal to positive terminal, but the conventional direction is from positive to negative. Come on, this question. Among identical spheres, there are two spheres. One is A, one is B. One is minus 5 coulomb, other is minus 16 coulomb. Which is at higher potential? Which is at higher potential? Right? So, what was the definition of potential? The amount of work done in bringing unit positive charge. More is the work done, more is the potential. So obviously it's less negative, है ना? So in bringing unit positive charge, है ना, I will have to do more work. It is more negative. So this will I have to do less work because it is more negative. It will attract more, है ना? It will attract less. So obviously I will have to do more work. They both will attract the positive charge which is placed over here, but here I have to do some more work than this case because it is minus 16 coulomb. We know that opposites attract, but as the magnitude will increase, minus 16, it is 16, it is minus but it is 16, minus charge with 16. So obviously higher potential is minus 5 coulomb. Clear? Because amount of work done will be more than this. Clear? So minus 5 coulomb is at higher potential. Chalo, start. Come on, solve this easy question. Really easy. Try to solve this question. Effective resistance between A and B is. This question you have to think something. This is not so easy as it seems. Time over. Okay, Now what you can see, you have to find the resistance between A and B, equivalent resistance. Effective resistance or equivalent resistance means the same. As we will move from here, you can see, okay, but what you see here, this point and this point are joined by a wire. Because they are joined by a wire and in between there is no resistance, means this point and this point are at same potential, and this has no resistance. The current will have an alternate path. Why it will choose this path when it has a least resistive path? आपके पास एक ऐसा रास्ता है जिसमें कंकड़ पत्थर भरा हुआ और एक रास्ता जो एकदम साफ है, आपको यहाँ पे डिसीजन लेना. ऑब्वियसली the road less taken. You must have read one poem in English. This will be the road less taken. No one wants to follow the resistive path when I can see a nice path over here. So obviously the current will flow like this and then into this. This is of no use. Current will not flow through this path. So obviously the answer is 4 ohm only. Now this was a tricky question. Whenever two points are connected by a wire which has no resistance in between, this means that instead of resistive path it will follow that path, because it had the option of going either this way or that way. So here the current will not be distributed. Clear? So that's what. Power rating of an electric appliance indicates amount of heat evolved, brightness of the light, quality of the appliance, or rate of consumption of electrical energy. Remember, power rating is 25 watt, 30 watt. What is the unit of what? Electrical energy consumed per unit time, right? So the rate of consumption of electrical energy, A or 1, is the correct answer, right? Next, when two or more resistors are connected in parallel, then come on, very easy, na? Only 10 seconds. Okay, current passing through each resistor is same. Current passing through each resistor is same. Potential difference across each resistor is same. Now parallel, these are in parallel, so obviously the current passing through each resistor will not be the same. This will be same only when the resistors will have same value. But the more correct is the potential difference across each resistor is same, because they are not given ki the resistors are having same value. So obviously when connected in parallel, the potential difference of V is the same. Clear? Next, the reciprocal of the combined resistance of any number of resistances connected in parallel is equal to, easy, okay, yes. So parallel, right? Reciprocal, right? Combined resistance or equivalent resistance. Reciprocal R1 plus R2 plus R3 plus how much, whatever amount of resistances you want to add to, plus read the statement, the sum of the reciprocals of individual resistances, or the sum of reciprocals of the individual resistance. Yes, because the question is asking the reciprocal of the combined resistance, not the combined resistance. Clear? Reciprocal of product, no, not the product. Reciprocal of sum of all the resistance. Reciprocal of sum means it is saying like this. So this is also wrong, है ना? This is right. So the first option 1 will be correct. Last question, है ना? The combined resistance of n connected in series is equal to, very easy, very easy, 5 seconds, 10 seconds. Okay, is equal to the sum of individual resistance, है ना. Combined resistance, equivalent resistance equal to R1 plus R2 plus R3 plus whatever. Clear? We'll keep on adding algebraic addition. So I hope you have understood the questions, marked your mistakes, है ना. We solved 40 questions in this session, है ना. So we have to solve more questions. We'll be solving more questions, and do comment your total marks, है ना, in the comments, है ना. I will see all the marks, whatever you have obtained. Clear? So I will be waiting for your comments. Thank you.